Now that we know what the slope of the tangent line is, and we know what a tangent line is, I claim that there's a slightly easier way than always having to draw the picture. If nothing else, we're going to have some formulas, and those are going to be called the derivative, that allows us specifically to find the slope of a function at any point. And so the slope formula is called the derivative of f of x. And there's a handful of ways that we're going to write this, and through literature you might see different ways. These are not the only ways, but these are going to be the primary ways that we'll see it. And so you could write it as f prime of x. That's the first derivative of x. That's the first derivative of the function with respect to x. You could also take the derivative notationally as d dx of f of x, or you could write it as y prime. All three of these notations really mean the same thing, but in different areas of math, one might be more useful than another. Now, let's do these formulas. So let's say that I have a function, and that function is a constant. That is, it's just a number. So f of x is equal to 2, f of x is equal to 7, f of x is equal to 25, c being a constant. And then what we're going to say is that to take the derivative of that function, and just once again different notations, the derivative of a constant will always be 0. Now, just as a side note, this is actually pretty interesting because if you have a function that's a constant, what does that look like? Well, that function looks like this. And then if you were to make a tangent line to an already straight line, then it's going to have to be the exact same line, right? And so the rate of change of a straight line is just going to be 0. So hopefully that makes sense to you. Well, then we're going to get the multiple of x rule. So what does that function look like? Let's say that you have a function that is a constant just times the variable x. Then specifically what's going to happen is when we take the derivative of that function, there's no need to write both of these, but they are equivalent notations. But when you take the multiple of an x rule, the derivative of c times x is just going to be that constant c. Now once again, if we think about this in picture form, a line, that's c times x, right? So let's pretend it's positive for that since it doesn't matter. But if I draw a tangent line to this equation, then specifically what's the slope of the tangent line going to be? It's going to be exactly the slope of the line that we started with, because a tangent line to a line is itself. Well then, let's consider the power rule. So let's say that I have some function where that function is x raised to the power r. Then I claim that when you take the derivative of that function, you're going to take the power multiplied out front, so it's r times x raised to the, and then decrease the power by 1, r minus 1. And so specifically, you get r times x to the r minus 1. That is the formula for the slope of a general power. Now, this one becomes a little more problematic to show you, because really, this is just going to give you the slope at a point on the function, and so it gives you a formula for slope. But now we just want to take some derivatives. So let's take the derivative d dx of x to the fourth. Well, general power rule is what it's going to apply here. So what happens? Bring that power out front. That's going to be 4 times x raised to the 4 minus 1, or 4 times x cubed. So now I claim that this is the slope formula for that function x to the fourth at any given point p. Now let's find y prime when y is equal to x. Well, if y is x, then the derivative, y prime, well, x is just our c times x function. And so that's just going to be c, where c is 1, and so that y prime is just 1. Also notice that if you use the general power rule, you'll actually get the exact same answer, right? 1 comes out front, and then 1 minus 1, x to the 0 power, you get the exact same formula. And so that is our derivative. That is the slope. The slope of the tangent line to y, or the equation of the slope of the tangent line to y is 1 here. So now we want to find f prime for f of x. Well, f prime, just take the derivative of this. Well, what's pi squared? Well, pi is not a variable. Pi is a number. And so since pi is a number, if you take a number and you square it, you're still going to have a number. Either way, that's a constant. So then the derivative of a constant is 0. Now we want to find the derivative of f of x is equal to 1 over x. And you may be thinking, wait, that doesn't look like any of the formulas we already have, but I claim there's a way to manipulate this. So, let's use what we know about negative powers to rewrite this. And so let's rewrite f of x, which is 1 over x. Let's write it with a power, so that's 1 over x to the positive 1. I'm going to then pull it to the numerator, and that's the same thing as x to the negative 1. Well, then I can take the derivative of that using the general power rule. F prime of x then brings that power out front, so that's negative 1, times x to the power minus 1. And so that's really going to be 1 times x, or x, raised to the negative second, which is the same thing as 1 over x squared. And so now I claim that you have a formula. Notice my typo, negative x squared, don't drop that negative, which means this is negative. And so then we have a formula for the slope of the tangent line to that function f. Now once again, let's talk through this. What do we mean when we talk about derivative? Well, the geometric meaning of the derivative is that if you're given a function, f of x, and you're given a point, you just pick some point. Let's say that point is a, f of a, because that's how you would find the y value, right? Then the derivative at a point at the point f prime of a is really the slope of the tangent line to the graph at that point. And it's kind of the slope of the graph when you're looking really close at it. Alright, and so specifically if you look at that point, and then you take the derivative at that point, whatever answer you get is the instantaneous slope, or the instantaneous rate of change when you zoom into that graph and look really closely. So in general, if you want to find the slope of the tangent line at a point, what do we need to do? First, we find the derivative of the function. Then, once you have the derivative of the function, whatever that may be, you're going to take and you're going to plug in a into that new statement, which is the derivative. Specifically, that notation is that you evaluate the derivative at a, or you get that the slope is equal to f prime of a. Well, then you'll have a slope. And if you want to put it into an equation, point-slope form is useful, just like we talked about earlier. That is, if you have y minus y1 is equal to m times x minus x1, you can use this to write this out. Now, specifically, that x1 corresponds to the a in my above notation, and y1 corresponds to f of a, because, once again, this is the same thing as my x1, y1 that we're talking about. And so that point of contact is going to be the x1, y1, which is the exact same thing as that a, f of a point. They're exactly the same. Then we're going to find the slope of the tangent line at the point, like we just talked about. That slope, remember, is the derivative at the point a. And then when we want to find that equation in general, specifically with the derivative, that's going to be y minus f of a is equal to f prime of a times x minus a. So now let's try this. Let's find the equation of the tangent line to f of x equal to root x when x is equal to 1/121st. And so specifically, I've got the graphs here just to give you the visualization, but we need to do this mathematical equation stuff because the picture may not actually help us. So first things first, let's find the derivative. So f of x is square root of x. But what could we do? Well, we could rewrite it using powers. Remember that radicals are really rational powers, that is fractional powers. And so specifically that is x raised to the positive 1/2 power. Find the derivative using the general power rule. F prime of x is equal to, take the power, put it out front, that's 1/2 times x raised to the 1/2 minus 1 power, which is really going to be 1 over 2 times x to the 1/2 minus 1 is negative 1/2. And then if you want, you could rewrite that, because that's the exact same thing as 1 over 2 square roots of x. I just used the fact that this is a negative power, moved it into the numerator, and then I put it back into square root notation for us if it makes you feel better. Well then, we need to do two more things. We need to find our point, a f of a, and we need to find the slope, f prime of a. Well, since we're already here with the derivative, let's find f prime of a first. So f prime of a, which is really f prime of 1 over 121, that's going to be 1 over 2 times the square root of 1 over 121. But that's going to be 1 divided by 2. The square root of 1 is 1. The square root of 121 is 11. And so that's going to be 1 over 2 over 11, which then becomes fraction multiplication, or 11 halves. And so now I know that this is my slope. Great. Well, I also need to find that point, a f of a, but we know that a is 1 over 121, and so now I just need to plug that into my function. F of a is just going to be the square root of 1 over 121, which is then 1 over 11, and so now I have that ordered pair, a f of a, which is then equal to 1 over 121 and 1/11. Then I can write the equation of the line, which is going to be y minus 1/11 is equal to the slope, 11 halves, times x minus 1 over 121. And then if I wanted to simplify it, I could, but for all intent and purpose, this is the equation of the line. It just depends on how we need to answer our question. Let's do it again. Let's find the equation of the tangent line to the graph f of x is equal to x cubed at the point x equals negative 2. So why don't we just find the derivative first? F prime of x, general power rule, that's going to be bring the 3 out front, times x raised to the 3 minus 1. So that's really 3 times x squared. Well then my slope, which is going to be equal to f prime of negative 2, is 3 times negative 2 quantity squared, which is 3 times 4, which is 12. Then we just need to find our point a f of a, but we already know that a is negative 2, so to find f of a we just take negative 2 and plug it into the original function. And so f of negative 2 is going to be negative 2 quantity cubed, which is then negative 8. And so I get the ordered pair, a f of a is negative 2, negative 8. Then, using point-slope form, y minus 8 is equal to 12 times x minus negative 2. And then let's finish the algebra on this one just to get it in a y equals form. So this is y plus 8 is equal to 12x plus 24 minus 8 minus 8. Y is then equal to 12x plus 16. And so in y equals form, there's our equation.